we're going to be doing pages 18 to 21 today. And question number 69 says, next, Bert and Ernie, our friends from Sesame Street, are work on solving the inequality 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3. And Bert asks, can't we determine the solution by looking at the graph of function of x equals x squared plus x minus 6? Part A simply asks, where does Bert get the equation f of x equals x squared plus x minus 6? And we've seen this before. Basically, what they're doing is moving all the terms to one side. We did it before with an equal sign. Now we're just doing it with an inequality and throwing an equal in there. Okay? So this x squared subtracts from the 2x squared to get your 1x squared. This 4x subtracts from the 5x to get you 1x. And this 3 subtracts from the negative 3 to get you the negative 6. Okay, so we move them all to one side. And generally you set it equal to 0, but in this case you're graphing it, so you set it equal to y. Okay, part B, they want you to graph it. So you can factor it first if you want to, or you can type it in Desmos, and it's going to give you this parabola, because it's a quadratic, and it's going to intersect the x-axis right here at positive 2, and right here at negative 3, okay? How can the graph help to solve the inequality 2x squared plus 5x minus 3 is less than x squared plus 4x plus 3? By combining it and putting it on, in this case, one side or the other, the solution will now be when the parabola is below, but it doesn't have the equal part, so not equal to the x-axis. So from here down will be that solution based on the inequality less than, okay? But not including this point or this point. We're just saying below it, okay? Any questions on that? All right, let's look at part C. Part C says, Ernie thinks that he can rewrite the inequality as x squared plus x minus 6 is less than 0. Solve it as if it were an equation to get boundary points and test numbers in the 2x squared plus 5x minus 3 less than x squared plus 4x plus 3 to see which regions the inequality is true for. Use Ernie's method to solve the inequality. Okay, so I simply took that trinomial, I factored it using the box, but you can always use quadratic formula if you want. You get the binomials x minus 2 and x plus 3. If you set each of those equal to 0 separately, you get the two answers, x equals 2 and x equals negative 3. Just like we got on the graph above, right? Intersected right here and here. That's the same as these two numbers, right? Okay. So what I did is I circled or put points on the line graph at positive 2 and negative 3. And once you get into your groups of 4, you need to decide, should they be open or closed? And where is the shading going to go? In between or on the lefts of right? Or on the left and the right? So in your groups of 4, you're going to try the 3 regions. Something from this area over here, something from this area in the middle, and something from this area on the right. Okay? We've done that before, so that shouldn't be too hard for you guys. Anybody still writing at the bottom of page 18? Okay, flip over to the top of page 19. Top of page 19 is another one of these questions. So you're going to, it says to use any of the methods you've learned to solve the inequality, x squared plus 3x minus 10, greater than or equal to 0, but then it gives you a coordinate plane. So they're suggesting do it by graphing, right? It's going to give you some intersections. So you're going to graph it on the line graph, check your 3 areas, see where your shading should be. Okay? Then we get to question number 71. Okay, in 71 is where we switch it up. We're going to switch from using one variable to using two variables, which is going to give us two different functions to graph. And if you want to use Desmos, it's going to help you quite a bit. Okay, so in problem 67 and 69, you looked at inequalities in one variable. Now consider the system of inequalities with two variables. So now we're going to have our x and our y. Okay, I did the first one highlighted in yellow and my second one highlighted in pink. Okay, based on the inequality of greater than or equal to, I know the shading is going to be above and solid. And then based on the inequality less than, I know it's going to be shaded below and dashed. Okay? So for the yellow quadratic, it's this skinnier one. You got yours is graphed on your paper, right? Okay. So it's going to be solid, and then it should be shaded above. Okay? Do you need to completely shade it in? No. You just want to do the slashes like I did, you can. Okay? The second one is the slightly wider one right here. And it is, because it's less than, it's shaded below. And you kind of need to make it dashed because it showed it as solid. So I just took the pink highlighter and dashed it in there. Okay? Because we have these two inequalities and we have two shadings, we only consider their overlapping parts as where the solution is. Okay? So the yellow is shaded above, the pink is shaded below. So the overlapping is in this middle area that kind of looks like a Nike swoosh. Doesn't that look like a nice Nike swoosh? First I thought it looked like a crooked smile, but then I'm like, no, it looks a little more like a Nike swoosh. Okay. So for part A, it says, which points make both inequalities true? Okay. So in order to make both inequalities true, it would need to be a point that lies in the region, that's the Nike swoosh, that has both shadings. If it only has one shading, it's no good. Okay? For example, does the point -3, 0 make both inequalities true? So based on this graph, here's the origin. You go 1, 2, 3 to the left, and you don't go any up or down, right? So it's actually right at this intersection point, and -3, 0 is true for the yellow, but technically not true for the pink. Why not for the pink? Because the pink doesn't have the equal part. Okay? The pink only has the dashed. So you say, no, it's only for the yellow. The pink does not have the equal part, so it's only part of the yellow. It's technically not in the pink. Okay? I almost said yes, but then realized, oh, that's dashed. So it's not, remember when we got something weird like 6 is less than 6? That's what you get right there. Okay? All right. Then it asks, what about the point -1, +1? So from the origin, you go 1 to the left and up 1, and it's only yellow. So it only has one shading. So that's definitely not in the overlapped area. And then the last point they have us check is 1, 5. So starting from the origin, you go 1 to the left, and then notice it's scaled, 3, 6, 9, whatever. Okay, so you go up halfway, well, a little more than halfway between 3 and 6. And that one is, yes, it's in both shadings. You can mostly see it here. You can even see it better if you were in Desmos and you took your little pointer and you hovered. It would show 1, 5 was in there for sure. Okay? Any questions on 71? Nope. Anybody still writing? Nope. Okay. Flip over to page 20. We're looking at question A. It says, what is the difference between a solution to the system of inequalities above and a solution to the inequalities in problem 67, which is also 71? Hint, think about what the difference is between a solution to an equation with one variable and an equation with two variables. Okay, so there are infinitely many solutions to a system of inequalities, and solutions for two variables is only going to be where the shadings overlap, which there are infinite amount of points in there if you count all the decimals and the fractions and the other points. Okay? One variable is going to give you the number line, like the top of the blue board over there, and two variables is going to give you the coordinate plane, so the x and the y axis graphing, and show you the overlapping that way. Okay? Part B says, how are the graphs of the equations y equals 2x squared plus 5x minus 3 and y equals x squared plus 4x plus 3 related to the graph of the system of inequalities? It says the solutions are all values where the colors overlap, but not exactly equal to the x squared plus 4x plus 3. And then part C, am I going too fast? Okay. Is that better too, to show all three answers at the same time? Okay. Okay. Part C says, with your team, how can you represent all the solutions to the system of inequalities? Show the solution to the system of inequalities on the graph. The region with both colors represents the solutions to the systems of the inequalities. Key right here is both, and you just need to be careful with the if you have a dash line, right? Or it doesn't have the equal part, so that you know if it's in that area or not. Okay? Like that one point that was right at the corner. It was technically in one of them, but technically not in the other. Okay? I'll give you guys a second to catch up with the writing. And then we have one more thing to look at. Anybody still writing B, or can I move up C? Right? Okay, we'll work on B and C, and then we'll come back to A at the very end. What I'm going to do at the top of page 21 is question number 72. It says, for each of the following graphs, write an equation, an inequality, or a system that represents the solution shown. Note that the equations for the line and the parabolas are given. So all of them have the same parabola equation and all of them have the same line equation. You just need to look at the graphs and based on the shading, decide what symbol should be between them, or if you write them as separate a separate system, what they would have between the y, okay? For instance, on A, you'll notice that there's no shading, okay? So what symbol would you use for that, okay? And then for part B, under that parabola, you have shading below it, but it's dashed, okay? So would you use greater than? Would you use less than? Would you use greater than or equal to? Would you use less than or equal to? And then the line is also dashed, but it's shaded above. Okay? So think what symbol you would need to insert, and you can either, well, probably the easiest way is just to write it underneath it. And